Hello.
Hi.
Hello.
Ciao.
Hello, everyone.
Hello. I think we'll just wait a minute or two, see if Xing or Raphael will be joining.
He's here.
Perfect.
Hi, everyone.
Hello.
Hi. Hi, Alex. Hi, Chris. Okay. So, sorry, I just arrived. So do I need to start presenting or not? Or we wait?
I think we have everybody here. Is Xing okay with you to start?
Okay,
Yes,
thanks.
of course.
Go for it then.
Okay. Can you see screen? Yeah, thanks. Okay, Leonardo.
Hi. Shall I start, David?
Yes, yes.
So, first of all, thank you for giving us your time and letting us present our project to the Stack Storage. Our project is Cloud-Native PG, and yesterday we applied to be into the CNCF sandbox, and we are here to present our project, what we do, and to have a lot of precious feedback about our application and about what we do in general. And so just a few words about me. I'm a principal software engineer working at ADB, a long-time PostgreSQL user and fan, ex-concurrent. I'm an open source contributor too. I work with Barman, Cloud-Native PG, of course, and I'm even lucky enough to have worked with Xing in the Kubernetes CSI organization, so contributing recently to the external snapshot project and the CSI driver hostbat. So, Gabri.
Gabriele Bartolini, I'm VP Chief Architect of Kubernetes at ADB. I'm a Postgres contributor. I've been using Postgres since 2000. I'm a co-founder and ex-member of Second Quadrant, which was acquired by ADB a few years ago. I'm also an ambassador for Data on Kubernetes. And thanks to DevOps, that's how I got into Kubernetes. And after having worked with Barman, a popular backup and recovery tool for Postgres, I'm now involved with Cloud-Native PG. So, we could probably talk for days and days about Postgres. This is just, I think we all know what Postgres is. It's a relational database. It's probably the world's most advanced database, not just in the open source arena. And it's fully open source. The license is called the Postgres license. It's similar to BSD. And the IP is owned by the Postgres Global Development Group, which represents all the developers in Postgres history, essentially. So it's truly free. It's extensible. You probably all know about pgvector. pgvector is an extension very popular in this era that transforms Postgres into a vector database. But in the past, there have been other extensions like PostGIS or even Timescale that are very popular and that make Postgres this multimodal database that we all know. It's the most popular one in the world. It's got advanced features. It's important to understand that it's a primary standby replication architecture. So this is not active-active. Postgres is primary and replicas. It's got partitioning, full text search, JSON support. It's ACID compliant, so it supports transactions. And there's a strong community behind it. So before we go into Cloud Native PG, our project, I want to go through a bit of the history of the project, because although we open sourced it in 2022, it was actually born 5 years ago. Okay, so we called the first era, which is up to now, the phase of bringing Postgres to Kubernetes. And that pretty much describes our approach, that was to bring Postgres to Kubernetes administrators. So that's why we took a different approach, for example, from other operators that were already present back then. In 2019, we had this minimal viable product with a fail-fast approach, and we saw that there was an opportunity. And we went ahead. We had this multi-master product called BDR at Second Quadrant, and we built this closed source operator from which we derived Cloud Native PostgreSQL. Then we were acquired by EDB, and the EDB had actually their own operator, and they decided to use the Second Quadrant one. And it was open source, but it became production ready pretty quickly thanks to IBM Cloud Pak. So IBM Cloud Pak was an early adopter, and they helped us grow as a closed source software. And we introduced high availability, disaster recovery, observability. We put a lot of attention into security and so on. And in 2022, for the Valencia KubeCon, in Europe, we released Cloud Native PG as open source. And we had actually applied as well for the sandbox at that time, but unfortunately, the application was rejected. And we kept developing the software thanks to the commitment from EDB. We've done in roughly 2 years, 10 releases, 3,400 commits. There's 120 plus contributors, 300 forks of the project. And since we open source, these are some of the major features we have introduced. I want to cite the multiple volume support for write-ahead logs or for table spaces, declarative role management, volume snapshot, backup and recovery, distributed topologies that Leonardo will show later, and managed services. And yesterday we applied for the second time with the new process for the sandbox. So I was mentioning that Cloud Native PG is a level 5 production ready operator. EDB was the first adopter, then IBM Cloud Pak, then Google Cloud, Azure Cloud, Tembo, and there's a list of adopters that keeps growing every day. It's fully open source. The license is Apache 2.0, and the IP is not owned by a company, but the Cloud Native PG community. So Cloud Native PG community is a vendor neutral and openly governed community, and this guarantees that the project essentially will always be free. We have two options: to donate this project to the Postgres Global Development Group and make it fall under the Postgres, let's say, stream, or to the CNCF to go in the Kubernetes stream. And our preference at the moment is to apply for the sandbox and go through the CNCF. Cloud Native PG supports. Sorry.
Hey, Gabriele.
Yes.
So what's driving the decision to to opt for the CNCF? Just at the
As we mentioned in the sandbox, it's primarily the possibility for this project to be outward facing. Okay, so be part of a broader system, so integrate with other projects that belong to the CNCF, and also all the governance model, that the diversity principle and values that the CNCF has been advocating for since the inception, basically is what we at the moment our priority essentially. But if we keep it with the Postgres community, I mean, no offense with, but it would be kind of a project within Postgres. We want to actually make Postgres available for everyone in the Kubernetes space and grow as well with Kubernetes and the cloud native ecosystem in general. And we actually have a good story about that in a few slides, that I think is a clear example of a new perspective, new point of view that running Postgres in Kubernetes brings to Postgres as well. Okay, and you imagine this project has been there for 30 years, and there are still new points, new perspectives that can be brought, and that are part of the daily life of a Kubernetes system, essentially. So that's why, I mean, our preference is to be part of a broader ecosystem. Okay, I think the difference is little in terms of IP and consequences for the project, because it's, as I said before, it's owned by a community. So as I said, to change the license, to change the governance, it will need, the majority of the maintainers, and I doubt that this will change, So anyway, thanks, Alex. So we support multiple installation methods, Kubernetes manifest, mcharts, even operator lifecycle manager. We reached 4,300 stars on GitHub this week. And we are now officially the first Postgres operator in terms of stars. I know it's just a vanity metric, but for us that, created this project from nothing, it's a big reward. Another important number is the 47 million downloads in GitHub, which means that this software is used in automation pipelines. Okay, so it means that people are using this operator to test their applications and test their procedures, which is great. It's one of the reasons why we created the operator. And this is the graph in which I put all the other operators for Postgres in Kubernetes, and you clearly see how this project is picking up in terms of adoption.
Hey, one of the things that will likely come up in the sandbox review is how does Cloud Native PG compare to some of the other operators, so
Yes.
like the Crunchy Data or Zalando one. Is there maybe like a simple explanation you can give here?
Yeah, I think we have some slides about it after, if
Okay.
Yeah, and Leonardo will also explain that. So the ecosystem of Cloud Native PG, I mean, the operator is the main component. There are 7 maintainers, 6 from EDB and 1 from Upbound. And there are multiple component owners. The project has several components. For example, the operand images to run Postgres. For example, the base one has pgvector installed, or there are Postgres images with PostGIS. We also test the Postgres trunk. Trunk is the last commit in the Postgres source code, which will be part of Postgres 18 next year. So every day we run regression tests to make sure that Postgres 18 doesn't break anything. We also have pgbouncer images for the pooler, then the charts, Grafana dashboard, the playground, and CMPGI, which is work in progress, is essentially an interface to make the operator extensible. We define Cloudnative PG a Kubernetes native database, and I'm using the guidelines from the book written by Patrick McFadden and Jeff Carpenter here about data workloads in Kubernetes. So we essentially leverage the Kubernetes API. So for us, Kubernetes is the single authority, and it's not a proxy to etcd, which is one of the main differences with the other operators that rely on, for example, Patroni to determine which one is the primary in a cluster. For us, the architecture and the topology of the cluster is part of the status in Kubernetes itself. It's entirely declarative. So for us, infrastructure as code was a priority. It integrates with monitoring tools and logging tools for observability. And we also have this secure by default approach where through convention over configuration, without specifying anything, we try and protect the deployment from most common security issues. Like, for example, we disable super user access by default. So if you need super user access, you can enable that through configuration, but by default it's not allowed. And this is the example I was mentioning before. There's one patch in Postgres 17 that I wrote. It's the smallest patch in Postgres history, but with the highest number of discussions. That's because we brought this new point of view about disabling alter system that nobody had thought in Postgres would be required. But for us, for the secure by default approach, we wanted to disable altogether the possibility to imperatively change the configuration of Postgres, and we introduced this option that will be in Postgres 17. So this is what essentially, we hope to improve Postgres by being in the ecosystem, Cloudnative ecosystem. Leo?
Okay, this is just a quick glance of what the Cloudnative PG operator does. So we define a new set of custom resource definitions. One of them is called cluster. And you can see here an example of that. It's not actually the minimal one. It's, let's say, interesting. So first of all, you see here you have a field inside the specification. It's called instances. It's called 3. So just to remark a bit what Gabriele said, here we are trying to develop a block that will fit inside an ecosystem. So it's not a complete solution. What happens here with instances is that you will get a primary Postgres instance and 2 replicas. This may sound subtle, but reality is other approaches. I mean, if we were to design this API from the DBA point of view, that would be called replicas, and the value would be 2, because the primary is implied. Here you get 3 instances, which we believe is something that Kubernetes user will expect. In the stateful set, you have a corresponding field that is called replicas. It's 3, exactly like the number of pods you will get. So now you have the affinity configuration. This is just telling the operator to put the Postgres workloads on the node that are labeled Postgres inside the workload label. We have a configuration of synchronous replication. We will discuss later what this implies, but it basically means you have one replica that is always kept at the same level of the primary. will receive all the transactions. The primary will wait until these synchronous replicas have all the data. And then you have the configuration for the storage. It's a simplified API. You can specify the PVC template should you like to. And for the wall storage, wall is actually the name of, it's more or less like a journal. Well, Postgres will write data before committing it to the actual data store. We highlight here that this approach is declarative, meaning that we are telling the system what we want to be deployed and not how to do it. So this is another differentiator. Okay, so this is what you will get once applied this cluster definition. This example has a Kubernetes cluster with 3 availability zones. In the first one, you have a worker node with the Postgres label, as we said before. And there, the operator will create 2 PVCs, one for the actual data store and one for the journal. It's called PG data and wall. Once these PVC have been initialized, you will get a new primary pod that is running the Postgres process. Then the operator will create a new service which will target the primary. It is called read-write because it can host read-write traffic and will forward the request to the primary pod. Then a second availability zone will be created, just like the first one. The PVCs will be cloned using the Postgres native tools from the ones of the primary node. And then you will get the fast replicas, which will be synchronous. We specified it before. The same applies to the third availability zones. And so these different availability zones are happening because by default, we are using a conventional web configuration paradigm here. We, let's say, we set an anti-affinity on the topology of anti-affinity actually. It's going to just be preferred and not required. You can specify if you want to require it. And then you will get another service, which is called read-only service. That service will target the replicas. It's not just this. You will get a new set of secrets, which are basically, they are used for the application to connect to the Postgres nodes using plain authentication. But as far as the single Postgres nodes, Postgres instance, they are using MTLS authentication. This is something that usually when you install Postgres manually, you don't configure because it is really painful to do it manually. But here, we are creating a new CA for each cluster, and from that CA, we are creating the leaf certificates. And also, we are using MTLS for mutual authentication, so for the pod from each other, both sides.
Yeah.
And we do that because we believe this is the less surprise you will have when you work inside Kubernetes. This is used everywhere, the same infrastructure. Gabriele?
Yeah, no, I wanted to say that maybe we took it for granted, but we're using replication at the application level, so at Postgres level, and not at the storage level. Okay, or the replicas.
Yeah, that's the problem with Postgres DBAs.
Yeah.
Okay, yeah. This is what happens. Okay, and now we have a big store destroying one availability zone. And what happened here? It happens that, first of all, this out of service is discovered by the Kubernetes infrastructure itself. It's not the operator periodically checking the health of the single Postgres instance, and even not some other piece of software. This is another differentiator from the other operators, which are using, let's say, something like availability template that you can use inside Kubernetes or outside, but this is everything inside. So once the readiness probe of the primary Postgres instance is failing, we are going to have a failover. So this is automatic, and the operator is going to promote the first, let's say, the most advanced replica to be the new primary. This is going to be the synchronous replica in this case. So the read-write service will point to the new replica, and the read-only service will stop pointing to the old replica that was number 2. Should the availability zone number 1 came up again, now we have a single authority of truth here. This is Kubernetes itself, the CRD itself. And the old primary will realize, even before, just before starting, that it's not the primary anymore, and will downgrade itself as a replica and reattach as a replica to the new primary. Okay, here, the RTO is really low, and thanks to synchronous replication, you will have 0 RPO in this case, if you use synchronous replication.
Leonardo, could you just elaborate slightly on the when you mentioned that it's not the operator that realizes that something's down, but the Kubernetes. So what exactly is happening in that process? Because I would kind of imagine the operator would be using some sort of liveness check on the nodes, and then make some of those changes there.
Okay, what happens is the readiness probe of when the readiness probe of the primary pod starts failing, the primary pod will not be ready anymore. The operator is continually using a watch, actually, is continually looking for the pod status. And once it discovers that the primary pod is not ready anymore, it will trigger the correct action to recover the cluster. That depends on many factors. So yeah, we have not a continuous, the operator is not continuously probing the pods. Sorry,
Okay.
given one thing for granted. The binary of the operator, it is inside the operator pod, yes, but it's also inside the Postgres pods. It is not inside the image, it is injected after. But that we call it the instance manager in that role. But what happens is that it is the instance manager which is receiving the probe request from the kubelet and is actually checking if Postgres is up and running in the less costly way to do that.
I see. So the operator sort of injects a sidecar into the running Postgres. Gotcha.
Exactly. No, it's not a sidecar. It's like the PID 1.
Oh, I see. Okay.
And it will be the instance manager starting Postgres and managing all the Postgres signals under the hood.
Okay. So it's monitoring the replicas as well as the master.
Mm-hmm.
Okay.
Yeah.
Thank you.
Okay, so I'll quickly go through an important characteristic of Cloudnative PG is continuous backup. Okay, it's been in Postgres for many years. It's technically called physical continuous backup, and it's important to say that this is not just a snapshot, one-time snapshot of the database, but really we can do point-in-time recovery essentially. So we can recover at any point in time from the first available backup to the last archived transaction log. So for continuous backup, there are 2 subcomponents. One is called the wall archive, and currently we only support object stores. And the maximum RPO here is 5 minutes. So at maximum every 5 minutes, a wall file, so the transaction log is archived. And then we have physical-based backups. Cloudnative PG supports taking backups from the primary or the standby, which is the default. It can be scheduled or on demand, and we support both object stores through Barman Cloud for hot backups, and Kubernetes volume snapshots for both hot and cold backups. So essentially the difference is that we can shut down a standby and take volume snapshots of all the volumes and then resume the standby without generating any downtime. That's the offline backup. And if the CSI driver supports it, we can leverage transparent, incremental, and differential backup underneath. We are working to improve these in the future, primarily through the CMPG interface. So this is a building block. We call it continuous backup, and it's essentially a Postgres cluster with the wall archive and the backup catalog, okay? So when it comes to recovery, it's essentially a bootstrap method. So you need to copy the volumes from an available physical base backup, and then you start reapplying the redo logs from the write-ahead files until you reach the target, which could be full recovery. So until the end, the last archived WAL file, or you could also use this as the basis for a physical replica. So for example, you can have another cluster in another namespace or in another Kubernetes cluster that is continuously replicating even through just the object store, so without any connection. Or you could even have delayed standbys. So if you want, you can have a replica that is lagging 8 hours from the primary, so that in case of a accidental delete on the primary, you can use that to recover quickly, quickly, sorry. Or, you know, if you have a target that is a timestamp or a specific transaction, you can implement point-in-time recovery. And when the target is reached, the cluster promotes itself. So for full recovery or point-in-time recovery, you use a backup from the catalog and you create a new cluster as a bootstrap method. And then you can use the WAL archive to get to the point in time you need, or get to the end of the write-ahead log archive. So Cloudnative PG introduces the concept of a replica cluster that is primarily used for disaster recovery or for reporting, for example. So it's essentially a cluster that stays in continuous recovery and it's not promoted. So this is essentially the difference between a recovery and a replica cluster, but fundamentally it's the same thing. This stays in replica mode, or using, you know, Postgres terminology, continuous recovery. So we can use these components that I showed to go beyond the single Kubernetes cluster to improve the disaster recovery capability of the Postgres databases in an organization. So we have another Kubernetes cluster. We use the continuous backup to create the replica cluster. And in the other cluster, we create an independent continuous backup location. So these two are independent. They effectively contain the same files, but they're totally independent. This is our preferred and recommended approach to achieve disaster recovery with Postgres in multiple Kubernetes clusters. And if we want to reduce the RPO between these two clusters, we enable streaming replication between the two. So this is how we recommend setting up a production cluster with Cloudnative PG in Kubernetes. So you have the WAL archive. The WAL archive can be used by the standbys as a fallback option. For example, if they've been down for a bit and they need to replay a lot of files, Postgres might choose the WAL archive to get to a point where it can actually stream. And then the backup catalog, as I said, we can take the backup from the primary or the standby. So Leo,
I have a question.
yeah,
Or maybe you are actually going to it to, okay, maybe I'll wait for your next, looks like you're going to explain to it.
okay.
Yeah, I was just going to ask this 3AZ thing, would that be, how that work for this 2 Kubernetes classes? Looks like you are going to explain.
Yeah, and
Oh,
this
yeah.
is a
Okay.
typical setup in on-prem where you don't have availability zones and you have actually 2 Kubernetes clusters nearby. Leo,
So what is going to happen is that you have 2 Kubernetes clusters, and then so exactly. So the second one will be a replica cluster of the first one. When we create it, we can use the backup of the first cluster, and also we will use the WAR archive to keep them continuously in sync. Then exactly we archive the WAR files of the second cluster inside the continuous backup area of the second Kubernetes cluster. So they are symmetric. And yeah, you can have a TCP connection going from the first cluster to the second one. For streaming replication, this is just like what we were doing before inside the same Kubernetes cluster. We are not speaking here about synchronous replication because that depends on the latency you have between the 2 Kubernetes clusters. And yeah, so what happens when something is destroying the first Kubernetes cluster? We need to promote the second one. As you can see, the primary of the second Kubernetes cluster is called designed primary, because from the Postgres point of view, this is actually a replica. The replicas are called cascading replicas. That means they are cascading from the design primary to the real primary. They were before. But when you promote the second Kubernetes cluster to be the primary, the situation is going to be just like the one you had in the first Kubernetes cluster. So here, the RPO is maximum of 5 minutes. Why it is 5 minutes? Because this is the timeout time of where the whole file was archived in the primary cluster. So the RPO is 5 minutes. It could be actually lower if you had that TCP connection. Here, the RTO is, it depends, it's manual, because when you tear down a Kubernetes cluster, it's not just the database. The database is what powers your application, but the value that you propose to the customer is actually in the application itself. So it's not just promoting the correct database on the second cluster, it is to adjust everything to actually bring the application back. So that depends on the actual infrastructure, on how it's done. Okay. You
Leo,
can.
you want to mention the switch over, the control switch?
Oh yeah, okay. So that was the
Which is
failover.
not.
You can actually do a switch over. That means you basically demote the first Kubernetes cluster that will give you a token. Inside the token, you have the exact status of the transaction log, where it is stored. Then you bring that promotion token, it's just a base 64 encoded JSON, to the second Kubernetes cluster. You set it inside the primary node, and what is going to happen is that the design primary will wait to have replicated everything, and then it promotes itself. And then you can actually bring your old primary as a design primary of the new one, because they are aligned. This is an exercise that several organizations do periodically,
especially
to
banks.
switch between different data centers.
Which might be, as Jing was saying, just nearby, as well.
Okay. Okay, you can go more, you can have more region than two. This is a cascading deployment. And yeah, okay, so
And,
Last question.
sorry, go on, Jane.
Just the previous page. Is it also possible to go from region 1 to 2 region? I mean, not like, but from 1 to 2 and also 1 to 3? Would that be also possible?
yes.
Okay.
Yeah, the token is ensuring that everything is aligned before promoting the new primary. For the switchover, for the failover, and you need to promote what you have.
Yeah, you're pretty flexible.
Yeah.
And we're not going into details here about the distributed topology. It's a feature that we introduced recently. But you can, you can organize topologies, as you prefer.
Hey, quick question though. When you have sort of multiple Kubernetes clusters, do you have an operator in each of the clusters, and do they therefore talk to each other, or is there just one operator?
No, it's just one operator installation per Kubernetes cluster, and they don't talk to each other. It's just the object store being accessible by having every Kubernetes cluster, or the famous TCP connection. But that goes from Postgres to Postgres. The operator is not actually involved.
Yeah. We provide the primitives to do this so that, for example, there could be kind of a superset operator, or something else at the federation or multi-cluster level that can coordinate the activities. Could be even be a GitOps
I see.
process.
So basically, on this slide, you have an operator
in each
of the three clusters.
Yeah.
And the operators configuring Postgres to do the periodic wall backups to the object store, and then in region 2, it's configuring Postgres
they're independent, yes.
to read.
Yeah.
I see.
It's kind of
Okay.
shared nothing. That's kind of the architecture we recommend.
So maybe I
That's
missed
clever.
So maybe I missed how this was deployed in the beginning. You have your operator in each cluster, then so you deploy a PostgreSQL cluster in each, and then
Yes.
set up this thing. Okay.
Yeah, maybe I can show you an example. Let me see. Maybe Leonardo, you go ahead and let me see.
We have one.
So this is the documentation. Actually,
We have one.
there was an article I wrote about that. So we have in the configuration, we have this section called external clusters. So these should be the same in every cluster you deploy. Okay. So this defines the distributed topology. Here we know that by looking at these that you have two clusters, one in Central Europe and one in Western Europe. And these are the object stores. So in this case, we only have object store communication. So RPO could be maximum 5 minutes. But theoretically, we could add a streaming connection. And this is the central one. Okay, and we say we configure the replica so that the primary is EU central. So it's itself. And in case this should become a replica, its source will be PG16 EU Western. Okay. So, and this is the Western one. So it's essentially the same. but it says that the primary is central and source is central. So when they match, this is a replica. When they differ, and the primary, it's the same cluster, that's the primary in the cluster. So essentially what we need to do is to demote the primary this way. So it's shut down and it's set in replica mode, waiting for the wall files to appear in the object store. And then we promote it this way. So the Western one is promoted in this case using this demotion token. So when it reaches that transaction, it promotes itself, and the previous primary resumes automatically as a replica. So we are the first, even outside Postgres, outside Kubernetes, there's nothing that does this. Okay, so, and anyway, there's an article that tries and explain. I hope it's clear, Jing.
Yes, thank you.
Okay, so for example, I've been talking with people from Red Hat. They're thinking of using this in ACM, Advanced Cluster Manager, just to give you an idea of the level of which one is in charge or responsible for this, Alex.
Gotcha.
Okay. Leo.
Okay. Well, you know, I'm the man of boring technical details. So storage, we require a file system on top of it. Postgres will not deal directly with block storage. It uses the file system as abstraction. PVCs are mounted with the read-write-once access mode and are far more important than pods because they contain data and they need to be totally synchronized. For backup data files, at this moment, we work with Object Store for the wall archive and for the backup too. In the future, we have a plan. We call this CMPGI, Cloud Native PG interface, which is no more than a gRPC specification telling, and the operator will use it to communicate with plugins. And you can, using plugins, you can extend the operator itself. It has several entry points. The backup catalog is kept inside the object store. We support volume snapshots. This is native to the operator, and that has been really useful for us because you can actually reuse the storage infrastructure that you already have with a standard API. This is so important.
And this is another differentiator, Alex.
Yeah.
Okay.
And
Okay.
we require storage to be consistent. So if you use more than one PVC inside the same Postgres instance, a simple volume snapshot won't do the trick. You still need your wall archive, your journal. We are going to apply it to get a consistent state, but definitely the group volume snapshot feature will help with this too, to achieve consistency across volumes. Okay, we are managing PVCs and pods directly. We don't use stateful sets inside our operator. This is another differentiator. You know, it's actually using or not stateful set is a different set of compromises. That means we had to create a new controller to do that. And we know that it's not an easy thing to achieve, but we gained more control over the Postgres global rollout strategy. You know, Postgres DBAs know that depending on the configuration change you need to apply, you need to apply it before to the replicas and after to the primary, or even before to the primary and after to the replicas. That depends on what you change. And the operator is able to discover that and issue the right rollout strategy, given the role of each pod. Okay, controlling pods manually and PVCs manually makes this operator able to do an online resizing of volumes, so actually reconcile the PVCs, and even help the user to decide the strategy to use when, say, a node goes down, and depending on if the storage is local or not, to actually reuse the same storage to power the missing instance, or to clone another one, or just to wait for the node to be up again. So it has more, say, customization. We hope in the future that Stateful Set will be able to do all of these, and we would be really happy to work with on this topic and to improve them. Once they will be able to support everything, would be awesome to use them. Okay, when we create PVCs, as we said before, you can just specify the size and rely to the default storage class to do everything needed, or just you can customize everything using templates. Using this system, actually using PVCs, you have a total freedom of choice of whether you use local storage or network. And you can install these basically on every available option. We use this standard, say, common layer of storage. This is really important for us.
Well, actually, what do you mean by those available options? I actually do not understand. What do you mean, like VMs? That's part of your solution? What do you mean by this? Oh, you mean you can deploy on those?
Exactly.
Oh, okay.
We are not tied to the actual implementation of the storage. That's what I mean. We use it as an abstraction layer.
Okay.
Yeah, and high-end users are actually exploring bare metal solutions more and more. You know, especially more Postgres hardcore users moving to Kubernetes, that they're interested in bare metal deployments. Yeah.
Okay.
We have a few helpers inside our kubectl CMPG kubectl plugin to quickly benchmark your infrastructure. This is important because you can already have a glance on the performance you can expect from a system. So it's not just a surprise, but you can already give a number of what happens. And then I'm trying to be quick. Okay.
So yeah, I wanted to mention that the creator and sponsor and the main contributing organization is EDB. I mean, this is something we had to put in the application. And yeah, we put some useful links. We're gonna share the slides of all the links that we put in the Sandbox application. I mean, I want to show the adopters. I mean, this is just to give an idea of, the number of users. So like IBM Cloud, I saw Piotr was here before. I don't know. I think he left from IBM. And as per IDB, Azure, there's also Google Cloud. I mean, that quite important adopters. And
Gabriele, can
yes,
I ask you to touch on two subjects maybe briefly? Where do you see data encryption in your stack? Are you leaving that to the PVC to figure out, or do you have some ties into secrets?
Yeah.
And then the other question is, you've got a very complex system when you start trying to test all these elegant features that you've presented. So what's your multi-cluster test harness look like? And is that part of a project, or is that another project that we should be talking about?
No, there are end-to-end tests.
And so that's that's orchestrating multi-cluster scenarios in your
There's
end-to-end?
also a project that Leonardo and I recently started. It's called the CMPG Playground that it creates two kind clusters, and we are going to show how this is done. But what we're doing at the moment, we create replica. The same thing can be tested using replica clusters. Okay, so the remotion and promotion can be done with two clusters, two Postgres cluster in the same Kubernetes cluster. It's the same process, you know.
So fault injection could be done or expanded upon in your end-to-end tests.
Yeah.
Awesome,
There's-
thank you.
There's
And then encryption?
okay, yeah. So as far as encryption, you have the option to delegate that to the storage. So in that case, we don't essentially even see it. Okay, but of course, all the data are not encrypted. You know. Otherwise, we leave it to the operand essentially. So to the Postgres engine. For example, there's a community project, Postgres project that is introducing TDE. I think it's driven by Percona at the moment. Or EDB has its own transparent data encryption feature for enterprises. So essentially, Postgres can use a key to encrypt all the content. And that's part of our enterprise offering at EDB. Okay, so you can do it at the database or at the storage level. Postgres itself doesn't provide that. Okay, so here are the end-to-end tests. So there's a lot of them, you know. So every time, so we follow continuous delivery. So every time we commit to trunk, we need to ensure that all the end-to-end tests pass. Okay, and this is how essentially we ensure that the software is stable. So let me quickly go through. Here I put some presentations I've done in the previous KubeCons, and I want to thank the other maintainers. Leonardo here we're speaking on behalf of them, all the contributors, and really EDB, not just for CMPG, but almost 2 decades of contributions in Postgres. So
Awesome work, guys. Thanks.
Thanks, Tom.
This is brilliant. Thanks, Gabriella, and all the team, Leonardo, etc. It's we're exactly at time, so you timed that perfectly as well. Unless there are any other questions, we can probably call an end to the call.
Can you tell us a bit about the next steps or in general the time frame? We normally, the TOC gives an answer.
Sure. So, there is a backlog.
Do you want to share?
I'll share the chat window. So all of this is public. There is a sandbox application board. The next review is October the 8th. And there are 10 that are going to be reviewed that day, and then there are another 12 that need to be scheduled. So the sandbox reviews are roughly once a month. So the next one will probably be. Actually, I need to double check the TOC meetings. We have a sandbox review. I think next sandbox review might be some point in December because of KubeCon. because November will be tied up. But
Okay.
but then there will be typically one of the TOC members might allocate one of us from the tag to do a review and provide an update, which we can do, and also share the recording from today. And then the sandbox review is actually a TOC meeting, but it'll be closed.
Yeah.
But the recording will be made available afterwards. And if there's agreement in the TOC meeting to take it to a vote, then the TOC votes on it, and once the vote is completed, and it requires sort of 66% basically to vote in favor, then you join the sandbox. But you know, based on today's presentation and obviously everything that we already know about Cloud Native PG, it stands in very good stead. So I think we should. There's a lot to be positive about this.
Thanks. Thanks a lot, Alex.
Thank you.
No problem. And
Okay,
thank you for all the hard work and for the presentation.
no worries. Thank you. Thanks, everyone.
Excellent.
Yes.
Thanks, everyone. Have a good rest of your day.
You too. Thank
Bye.
you. Bye-bye.
Bye bye.